Okay, so we are now live. Yeah, so I want to welcome everyone to Summer Prelude, part 1 of 2, where we're going to showcase some of our interns this year, interns that are joining us for Google Summer of Code and Code for GovTech's DMP program. Because we have so many interns that are joining us for music blocks development. This first installment of the Prelude is dedicated to music blocks development. And we're joined here by our mentors, Walter Bender and Anindya Kundu, as well as myself, Devin Ulibarri, and they'll introduce themselves in just a second. And then we're going to have our interns show us the work that they'll be doing this summer. So we have Ajeet Pratap Singh, we have Shaik, Khadar, Vali, Mubashir Shariq, Abhijeet Singh, and Karan, Palan. So we're really excited. This is the first time we've done this. But you know, we're doing this for a couple of reasons. One is just to document the process so that we know, you know, where we came from, you know, when we look back on this at the end of the summer. Also, so that, you know, a year from now, when future contributors are working on the projects, they can kind of see where we came from. We're also doing this, you know, just, you know, for our own interns' learning sake, so that, you know, they can, you know, learn more about their own learning. We're also doing this for you watching, so that you can get an idea of some insight into what we're doing this year with music blocks and music blocks development. So again, my name is Devin Ulibarri, and I'm one of the mentors for the projects. I'm mainly helping out with, you know, the music side of things, making sure that that all of the things that we're doing make musical sense. So with that, I'll pass it off to Anindya to introduce himself as one of our mentors.
Hello, I'm Anindya Kundu, like Devin mentioned. I'm from India and I've been part of the Sugar Labs community for a little over 4 years now. So I met Devin and Walter when I was trying to participate for Google Summer of Code back in 2020. So that was 4 years back. Now, you know, I professionally work as a software engineer at Sorcero, and I really so after my summer of code back, my project in 2020, I took the initiative to drive an effort to like rebuild music blocks to address some shortcomings. So I am like overseeing the development of the upcoming version of music blocks. That's the version 4. I have over the last 4 years, I mean, summer of code 21, 22, 23, and this year, mentored. I mean, until now, I've mentored 9 projects. So this is my 4th year of mentoring, and I'm mentoring 1 more project this year. I think that's enough for my update. Back to you, Devin.
Yeah, so you were a contributor just like the folks we're going to hear from today, and now you're a mentor. This is a great kind of success story. Walter, I don't know if you're able to just introduce yourself briefly.
Sure. I'm Walter Bender. I'm another one of the mentors for Sugar Labs and Music Blocks projects. And Devin and I are the ones that sort of conspired to get Music Blocks started to begin with. And it's been really important to the project to have the input from the interns over the years. Like in India, we learn a lot from them. They get a lot done, and hopefully they're learning a little bit along the way. So again, super excited about the projects we have queued up to talk to you about today, and I think we should leave the rest of the time to the interns.
Yep. So with that, we're going to start with Ajeet Pratap Singh. He's going to tell us a little bit about adding real-time collaboration to music blocks. So Ajeet, if you can. Yep.
Yeah, thanks. Am I audible?
Yes.
Okay. So hi everyone. My name is Ajit Pratap Singh, and I've been selected for the project Add real-time collaboration to music blocks. And this summers, over the next 3 months, I will be implementing the real-time collaboration project to the music blocks. That project will let the music blocks users collaborate in real time. So. Should I present my project?
Yeah, absolutely. You can just, share your
Okay,
screen
okay,
or.
okay. So I will be sharing my screen. Okay. So hope it's visible to everyone.
Yep.
Okay. Uh, so uh, this will be my project. My project is the add, as I have already mentioned, add real-time collaboration to music blocks. In upcoming slides, I will be talking about five core points of this whole internship. First, I will be walk you through the introduction of the project, what the project is, and how we are going to uh, implement that project. Second would be a few details about the project, why we are doing that project, and what is will be the impact of this project. Third point will be what we are going to execute. What are the things that we need to execute in order to reach the end goal of this project? Fourth one would be how we are going to execute. There would be some mechanisms, there would be some uh, things, there are some ways that we are going to execute. And in the end, there will be the end result, what we are going to accomplish after the 3 months, after the end of this project. So first one, the introduction. So in this period, I will be working on a real-time collaboration project that will let the music blocks users collaborate on a project in real time. The project will play a major role in making the learning more interactive and fun, encouraging students to spend more time exploring and creating music. The purpose of this project is to foster collaboration and teamwork, leading to a richer learning experience. Now, coming to the important part is the project, what the project is. So, currently, we can make cool and interactive projects in music blocks. But what if I want to collaborate with my friends and who are far away from me? So here is the need of a collaboration feature that we already have in Turtle Blocks. So this project I will be working on will let the music blocks users collaborate with their friends in real time, the same like the Turtle Blocks. The collaboration will bring greater fun in project creation and will make learning more effective and interactive. Now coming to the next point, that is what to execute. What are the things that we have to execute in order to accomplish the project? So I've written some five brief points that I will walk you through. First would be the unique ID creation and assignment. So first of all, the thing we have to implement, that would be the creating a unique ID, a temporary unique ID for a user, and assign it to the user. So in order and this is because we want to track a user, what the changes the user will make, and according to those changes we have to sync the changes to all the connected users on that network. Second thing would be to distribute the same state of the project. So when we start the collaboration, all the users will be connected on a network, and in order to for a real time collaboration, the same state of the project will be shared among all the users, and so that they start doing collaboration. The third point will be the third point will be synchronization of the changes. When a user will make the changes, it's that changes will have to get in sync with all the projects that are connected through that particular network, or we say room. After that, there comes conflict management. So conflicts are in any collaborative environment. Conflicts are very normal, and so for the conflict management, as we are already will be using a CRDT mechanism that takes care of most of the part of conflicts, like auto merging and giving the priority. But there will be some instances where we have to implement some custom code as well for the conflict management. For that, I will be talking after some few slides. And after that, there is saving the final project. So in a case when all the users will leave the room, we have to save the project. We have to save the final project with final changes to the server side, or we say globally. Now, after that, there are steps, and there are steps on how we are gonna execute these things. So first of all, there is a first step that was to create a unique ID and assign it. So for that, I will be leveraging the mechanism we already have. As in current state of the music blocks v3, we already have a mechanism that creates a unique ID and assign it to the project. So the same mechanism I will be using for the users. The temporary IDs will be created and will be assigned to the users. After that, there will we have to implement a separate route for the common space. That route will work as a sort of room. So where the our users will be, and they will have the project in the same state, and that room will be used to collaborate in the real time. After that, we have to implement the synchronization in real time. So for that, we will be using YJS to track the changes, and WebSockets to send the changes over the server, and to obviously sync the changes. After that, for the conflict management, we will, as I have already mentioned, we will be using CRDT mechanism of YJS, and also some custom configurations that we will be implementing later. And for the saving of the project part, there will be two main instances when we will have to save a project. One in case one user leave the room. So in that case, that the user who will leave the room will have the project saved locally to their side. And in a case when all the users leave the room, the project will be saved globally, and it will be saved more preferably, as discussed with mentors, from the end of the user who initiated it. And after that, I will be moving towards some challenges and edge cases we will be facing. First will be, what if multiple users make changes at the same time? So that it's very intuitive in a real-time collaboration project. So for that, as I've discussed with mentor, so we will be giving a priority by their joining order. So if user A joins first, then user B, and if in a case of conflict between user A and B, the changes of user A will be considered first. And now coming to the second one, that is, what if a peer lost the network connection unexpectedly? So for that, I think YGS have a offline feature as well. So what it does is, it keeps on tracking the changes when a user is offline, and when the connection returns, YGS framework try to synchronize the changes with all the connected peers. And after that, we have another edge case is, what if a user joins late and a lot of changes has been made in the project. So for that, in such case, what will happen is, the user will get the current state of the project. He will not get the original state from where the project was started. Now coming to the next one, what should be the limit of peers to join the common space? As this was already mentioned with already discussed with mentors, this the first priority of the project is to get the project up and running, and after that, once we have a project running, we will test how many users it can have, and we will test the limits of that project, and we will be deciding about it later. And coming to the next one, what if the user exits from the common space and joins after some time? So as I've already mentioned in this one, the user will get the current state of the project. And now coming to the next one, what if user closes the window by mistake? So in this case, what will happen is, if a user there is a mechanism I documented in my proposal. There is a mechanism in YJS and YJS as itself, that if I for a particular for a particular time, if a user is not present in the room, the uh, the server will keep on trying to make a connection with that particular user with a particular ID. And if a user is not able to get connected with the room within a particular time, uh, the user will be exited automatically. And after that, if a user want to join again, they have to click on that link again and join as a new user. As we don't have any plan to store the user's ID permanently. So for in that case, the temporary ID would be deleted, and the user would have to join as a new user, creating another new ID. And the last one is few edge cases that will be encountered during the implementation. So such edge cases we will be considering at the time of implementation itself. And in the end, by the end of the internship period, we will have a full-fledged real-time collaboration functionality that will let multiple users make projects and collaborate in real time. That would be a really cool project, and I think it would make the project creation in music blocks actually fun and more interactive. Thank you so much. It's from my side. Up to you, Devin.
Great. Thank you, Ajeet, and thank you so much for going first. So next, we have Khadar presenting Make Your Own Lesson Plan for Music Blocks.
Hello, Devin. Can you hear me?
Yes.
Okay. My project in Google Summer of Code is make your own lesson plans. Like in this project, we'll be creating a own lesson plan for every project in the music blocks. There are several projects in the music blocks in which some of them are having lesson plans or some of them are having no lesson plans. So we will be using a generative AI support, and we will be generating a lesson plan for the all remaining projects. Okay, I will be sharing my screen. Yeah, can you see my screen?
Yes.
Okay. Okay, now I will be discussing about the project. Before I start, I would like to thank Devin and Walter for giving me good guidance while I am like understanding the code base of the music blocks, and my parents for supporting me. Yeah, now I will start. Yeah, myself I am Khadar, and I am a second year undergrad at RVC Bangalore. I am an AI and web enthusiast. I am selected as a GSoC contributor in Sugar Labs. Okay, coming to my project, as I have discussed, we will be creating a lesson plan generator for all the projects in the music blocks. We will be having a chatbot like system so that the user can interact with the chatbot and can generate lesson plans for all projects in the music blocks. And we will be using LLMs and generative AI support for this. Now let's discuss about our project, how we are going to building the project. We will be training our model with the data using the React technique. We are having the guide and the structure of lesson plan and the lesson plans of specific concepts in music blocks and the JSON data for the project. This is the data which we have available. By this data, we have to train the model, and we need to generate the model in such a way that the model should be capable of giving the lesson plan for us. Okay. As the GSoC project, we have already started. When we have started the coding around 1 week later. What is the update in the coding around this 1 week? I will be discussing. Okay, we have trained the model with a guide of the lesson, guide of the music block system. I have divided the guide into several PDFs based on the table of contents, so that when we are training the model with each PDF as a chunk of the data, the model can process the data easily. Like if you are having the complete guide as one chunk, and if you are giving to the model, then the model will not be capable of understanding the complete data. If you are dividing the data into several PDFs, and we are dividing it. I will discuss these points in the next slides. Okay, why we are using RAG?
Khadar, real quick. The sound was dropping out. Maybe you can turn your video off real quick and then just take a step back. We can, yeah, and then just go back one slide and then start back. Yeah.
Okay. Yeah, now can you hear me, sir?
Yes, and then continue from there. Thank you.
Okay. As we have already started the coding period for the music blocks, we have already done some work for regarding our project. I will be explaining the project. What is the work which I have done? I have trained the model with a guide of music blocks. Okay. The guide includes a number of table of contents. The guide is a big PDF. I have divided the guide into several PDFs based on the table of contents, so that the model can understand the concept in a detailed manner. If you think, if you are guiding the model, training the model with a complete guide, then the model cannot process the data easily. If you are dividing the data into chunks of a PDFs, and then we are training the model can process the data easily. And I have also added the sentimental analysis for the chatbot, and I have also added this assistant. I will discuss about this point, like what does this point mean, in the next slides. Okay, now I have used a RAG model to develop this project. Why I have used a RAG model? Because it is easily available in the market, and also it is better than fine tuning the model. Like fine tuning is a hard process which takes a lot of time, and also we have to have a more data for fine tuning. So I have used the RAG model. Also, RAG model updates itself in the, like if you are fine tuning the model, it will be up to a certain extent. Like if you have fine tuned up to September 1st, then up to only September 1st data only it can remember. If you are using the RAG model, then the model can remember the next year coming data also. So how are we going to build? I will explain the RAG model. As you can see in the flow chart, when the user asks the question, the LLM will retrieve the answer, and it will send to the user. It is the user perspective. If we see the flow chart, first we will start from the PDF, and we will be dividing the PDF into several contents, and extract the pages to the PDF, and split the data into chunks. Why we have dividing into chunks? We are dividing into chunks so that the model can understand the data or process the data easily. And we will be using embeddings API. We are using here Hugging Face embeddings API, so that the embeddings API helps that it will process the data and send to the LLM. In this process, the embeddings API is used, and it will. We are using the FAS and ChromaDB as data centers. This is an Facebook. It provides an open source program in which we can use FAS and ChromaDB as a data center. And when the user asks question, these embeddings API, as I have mentioned, it will reach the data center and extract the relevant data, and it will rank the results based on that. It will rank the results based on that, and it will send it to the LLM. Then the LLM will like generate the answer based on the ranked results, and it will give it to the user. Okay, I have told that I will be explaining the fourth and fifth point. Like if you come to sentimental analysis, if you can see, first the chatbot would ask, "Hi, welcome to Music Blocks. What is your career?" Then, as we have still trained the model only with the guide, I have asked a question: what is the use of phrase maker in music blocks? It provides us a complete answer. If you want to elaborate, we can ask, can you please elaborate it? Then it will elaborate. And I have set the model like good. Then it will say, you are welcome. I am glad I could help. If you have any more questions, feel free to ask. Like it is of sentimental analysis. If we say bad, it will say like, okay, sorry, can you please provide more data, like, so that I can process and tell you. And coming to the session set, as I have said you, if we give it a prompt like, can you please elaborate it, the model should be capable of remembering the previous question also. So that is what added by me. And these are the little points which I have also implemented. Like, I have created a structure of lesson plan for all the projects. The structure is fixed, so that I have created a structure of lesson plan, and I have I have used a drag model, and I have trained the model. I have asked questions based on that. Can you please tell me the structure of lesson plan? The structure of lesson plan includes lesson title, introductory statement, goals, introduction, concepts, key events. Okay. Okay. According to GSoC, the plan for this week is I will be working on building a conversational chatbot so that it is capable of remembering all previous conversation. The conversational chatbot is different and session chatbot is different. The session chatbot only remembers that session information. If we are using conversational chatbot, it can remember 2-3 days back information also. So that is what I am building. Also work on training the model with lesson plans in music blocks. If the time permits, I will work on the second point. If not, I will work on the next week. That is from my side. Thank you.
Great. Yeah, thank you so much for that report. So next we have Mubashir. We're just going to do a little sound check before he starts, though, just to make sure the sound is working. So if you can unmute yourself.
Hello, can you hear me?
Oh, yeah, I can hear you just fine.
Can you see me? Is my video clear?
I can hear you, but I think that's the more important thing right now. So you can leave the video off if you need to. I know you're having maybe some like bandwidth problems.
Hello, everyone. I am Mubashir and I have been selected for this year's Google Summer of Code with Sugar Labs, and I'll be working on musical transcription and assistance via generative AI. I'll share my screen. Is it visible?
Yeah, perfectly.
Yeah, so we'll be working on this project, musical transcription and assistance via generative AI. And my mentors will be Walter Bender and Devin Ulibarri. So the introduction of this project is that we'll be developing a tool that will convert the musical ideas of a person and user into musical compositions with music blocks code. So the main components of this project will be an in-app interface where a user can upload his audio or he can record his audio, and we'll be having a deployed server-side LLM service which will analyze that audio file and convert that into music blocks code. And for the front end and back end communication, we will be using APIs. And as per of now project, we have taken this React for front end and Fast API for back end. As per the motivation is concerned for this project, it will enhance the educational experience of students. They can easily record their voice, or they can just clap or something, like they can upload an audio file, and they can play with the music loss code there. It will foster creativity and innovation within the Sugar Labs community. Uh, as per my background is concerned, and I am an active contributor at Sugar Labs from December, and I have worked on several issues. I have successfully closed around 10 PRs, and few of them are like I added a recording button in sampler widget to see the waveform of recorded file and use that into the music blocks code. and other peers also I have worked like adding toggle console button in JavaScript editor. So what we are building this summer is like there will be two parts. First, we have to create an in-app interface for recording audio, and we'll be deploying an LLM service, and that will analyze and transcribe our audio. And to connect our front end with back end, we'll be using APIs. So for as per now, we have as per of now research, we are using this basic pitch by Spotify. Basically it what it does is takes an audio file, and it will be converting that audio file into MIDI, and I am working right now on converting that MIDI into music loss code. So that's as per of now project. And the tech stack we'll be using is JavaScript for front end. Audio handling will be using this Mozilla Web Audio API, Media Recorder API, and Python for server-side functionalities. For this LLM part and transcription part, we will be using Python. Frameworks, we will be using Fast API for server routes, and Web Audio API for audio processing, and LangChain for LLM integration. And we'll be using open source transcription API. As I mentioned, we'll be using basic MIDI by Spotify, basic pitch by Spotify for pitch bend detection and extracting notes from audio. So this impact, the impact of this project on Sugar Labs it will improve learning experiences and engagement, and new users will be attracted to us users with this feature that they will be using their sound, or they will be uploading any audio file and it will be converted into music loss code. It will be a great feature, and they might get inspired for such future projects, like such an amazing projects like these projects to work on with Sugar Labs. Thank you. That's it from my side.
Okay, great. Thank you so much. So the next presenter couldn't attend at this particular time, but I have, he sent in a video beforehand. So next is Abhijeet Singh. I'm going to stream that video and we'll just watch it together. Abhijeet Singh is working on musical ideation through generative AI.
Hello everyone, I'm Abhijeet Singh, and in this Google Summer of Code, we will be building musical ideation through generative AI. A little bit introduction about myself. I'm Abhijeet Singh. I am interested how things work internally, make them even better, optimize it, and I like to tackle complex problem. And I try to play guitar every day and have some experience in music theory. So what we are going to build in this GSoC 24. So we are going to implement a feature that is musical improvisation through generative AI and music blocks. So what does feature implement? So suppose a student wants to create harmony, and it needs some hint or suggestion how they could improvise those harmony, or wants to complete his harmony. So there would be an LLM by their side to complete those harmony, improvise it, and the possibility is endless. So why this project? Because after implementing this feature, there would be a lot of endless opportunities by this using LLM. And another reason was that I could use my whole skill that I have some experience in music theory, I have some experience in software development, and now while implementing this feature, I could use all my skills. So how we are going to build this feature? Basically, here's the flow chart for it. So user starts composition in music blocks and request LLM for improvisation, and then user send a request. I want to improve this harmony. Would you improve it? So basically, those LLM would be trained on ABC format. So those music blocks would be needed to convert to ABC format. Then once it's converted, the LLM would improvise it, complete the harmony, and give those response in ABC format. And then we convert those ABC format into music blocks and show it to the user. And there would be feedback feedback flow back. So where user could have their feedbacks or enhancement feature, which helps LLM to improvise it. So moving on to the next, why ABC not MIDI or Lilliput? Initially we thought MIDI would be a great choice because of musical standardness, but when we dig a little bit more, we found out that MIDI have a lengthy sequence. When we convert those into music blocks, it would take a lot of resources space, and that we don't want it. And also when we train MIDI on LLM, it require high extensive resources, and it also have issue with tokenization and a lot of stuff, and that's why ABC was a better choice. Also, if you want to dig a little bit more onto this, there is a research paper on chat musician which tells why ABC is better to use for LLM, and you could check out those research paper. So basically, ABC has high compression rate, they have repeat notation, and so when we convert those into music blocks, it could. Hello everyone, I'm Abhijeet Singh, and in this Google represents the title of the song, M represents the time signature, K represents the default length of the note, which is quarter note, K represents the key of the song, which is in key of C, and then we have the notes. So here you could see that we are going through up and down the scale of C. And also, if you see that in ABC notation, this whole thing is very much in compressed format, which help us in conversion of ABC code, ABC notation to the music block. Because if you check this in MIDI, that's going to be very long sequence, whereas in ABC format, it's very highly compressed, and for repetition, we have repetition notation for in ABC notation. In MIDI, we don't have it, and this also causes a lengthy sequence. Moving on to the next, that is progress till now. So we have almost completed the ABC parser to music blocks. There is some issue we need to fix it by the end of this and next week. The whole ABC parser will be completed. Basically, there is some issue with time signature and triplets, quadruplets, and those. So we are creating a generic form, so the time length for those would be in the generic format. Next, there is some issue with repetition. So if there is a repetition, we need to add a loop onto those. So we need to check out those. And with this, our project would be, or ABC parser would be implemented, and then we'll be implementing the integrating the LLM with the ABC parser, and then whole project, whole flow would be completed. So the thing would be user implement some harmony in music blocks, then it would be converted into ABC, and then it would be sent it out to LLM to make the conversion. The LLM would convert those ABC, improvise those ABC notes, and completes those ABC, and then we have ABC parser that converts those ABC into music blocks. For you might be thinking that we also need to have some code for music ABC music block to ABC, but in music blocks we already have functionality to convert codes into ABC format. We just only need to convert ABC to music blocks. Now, if you are excited about this feature, so we have pull request. You could check out those pull requests. That is pull. You need to go to music blocks, and we have. You just need to check out the pull request. That is 3837. I release daily a blog post on this implementing this feature at Medium at YU Abhijeet. And if you have any doubt or any question, you could reach us out on Sugar Matrix Lab, and I will be there to help you out. With this, thank you everyone.
Awesome. So that's Abhijeet's presentation, and now we move to Karan Palan.
Yeah, so am I audible, visible,
Yes.
and is my screen visible?
Yes, it is.
Yeah, so First of all, welcome all the community members and the viewers watching us on the summer prelude of Music Blocks. So, yeah, about me, I am Karan Palan, a freshman at Manipal, Jaipur from India. The project that I'm working on is called as the Masonry Framework Integration, and the primary tech stack that I'll be using is React and TypeScript. So, like, what is Music Blocks? As you might know, it is an educational tool that teaches musical concepts and programming through visual and interactive blocks, right? So why do we need a newer music blocks? So the existing implementation of music blocks is done in like vanilla JavaScript, and it lacks like modern front-end tooling, and it also lacks separation of components. So hence we have this new project called as Music Blocks V4, which uses all this stuff like React, TypeScript, SAS, and other stuff. So, like, what is the Masonry framework? It is the graphical blocks manager module, which is used to create like the music blocks programs, including like start, rhythm, note, pitch, and other breaks, right? They can be dragged from the palette and dropped onto the workspace to perform actions, right? So, by implementing this project feature end to end, users will be able to create musical patterns seamlessly. So, yeah, this is the demo, right? As you can see in the Music Blocks V3, we have this brick, and yeah, when you connect this brick, this is called the stack of brick, right? And all these actions are getting performed in the workspace, and this is the palette, right? So yeah, these are the major parts of the Masonry framework: the brick stack, the palette, and the workspace, and that will be the things that I'll be working on this project. So what me and my mentor Anindya Kundu have been working on for the last community morning period and the last week. So a design document which contains the PRD, architecture diagram, and the technical specification. So I show you here. So yeah, this is the PRD, which contains everything regarding the design of the music blocks. Like we have these brick types, these data bricks, expression bricks, these block bricks which contain nesting, the everything about the brick appearance, the brick interactions, like what are we gonna have, and like what is the stack of bricks, or what are we gonna add. Like we are gonna add this stack validation feature from like Blockly, which is gonna improve the UI for the users. And how are we gonna have the palette structured? Like in the older version of music blocks that we have right now, we are having the palette like this, but we are gonna implement the palette in a way that it is implemented in Scratch. So yeah, these are all the design decisions that we took, and yeah, as you can see, we also worked on the technical specification, and this is the list of all the functions, all the components that will be required to do all the stuff. This is the architecture diagram that me and my mentor worked on. This is the data flow diagram. We also had done some work on the UML diagram, and yeah, this is what you can see here. So like, yeah. So like, why is this helpful? So it is like we can catch errors early, like finding and fixing problem before the coding starts, and like we have made better design choices than what we have now, so that we are clear on the code implementation. And yeah, so what's next? We start coding, and like thank you. We would love if any contributors could join our project this summer. So by the end of this project, you would have this functionality of dragging bricks on the palette, connecting it to a stack to form a stack, and yeah, dragging it around in the workspace by the end of the summer. So yeah, that is all I had, and thank you.
Awesome. Thank you, Karan. And thank you, everyone who's presented. We do have a little bit of time right now if Walter or Anindya, you know, the mentors have any questions or clarifications, you know, or anything else you'd like to share in these last minutes. Now might be a good time.
Well, I just want to first say thank you to everyone who presented. Really, nice ideas, nice solid work. And thank you, Devin, for organizing this session. I do encourage people in the audience who aren't familiar with music blocks to check it out, and also check out some of the documentation. There was mention, for example, of a guide and some lesson plans and the like. And I know that those are probably somewhat abstract concepts without having to actually having experienced or seen it. So I think it'll make some of the presentations and some of the design decisions that were discussed a lot more tangible and understandable. You'll understand a little bit more of the rationale of the presentations by being a little more familiar with the project itself. So I just encourage everyone to do that. It's a fun project, and it's going to be even more fun once these guys get their hands on the code this summer. So thank you.
Yeah, and on that note, I put it in the chat right now. I don't know if that always goes through. I'll also put it in the description for this channel. And there's more videos on this channel that can give you an introduction as to how music blocks, how you can get started with music blocks. And there are also some videos of some sampled projects that you can check out as well. But the URL that you want to go to, it runs in a browser, is musicblocks.sugarlabs.org, and that's no fancy spelling, just music, blocks.sugarlabs.org. I know Anindya said he was kind of busy, so I don't know if he's able to jump in. But yeah, I just want to echo, thank you everyone who presented today. I think that was really great. So on this note, maybe I'll just say real quick a little bit about Sugar Labs, and this is all part of a series that we've been doing. Sugar Labs is very much growing right now. We're a US-based 501c3 nonprofit, and right now, we could benefit from contributions of any kind. If you're interested in donating, there's a few ways to donate on our wiki. If you go to wiki.sugarlabs.org, there's a link to the ways to donate. As you can see here, we're focused on education, and specifically, within the domain of computation, and all the things that touch upon computation. And one of the easiest ways to donate is through PayPal. If you're just watching this at home, you can go to paypal.me/sugarlabsinc, or you can just send your donation to donations@sugarlabs.org. Karan, I can hear your mic. So
Sorry.
it's okay. So your donations will help us grow. It'll help us do more great things, such as continue doing broadcasts like this, continue making great tools for teaching and learning, and reaching more teachers, more students in the U.S. and around the globe. So I guess with that, I guess we can end early, but I hope that everyone's excited to work on this summer, and thank you so much again.
Thank you.
Thank you.
Okay, I'm going to end the stream.